This photograph proves that the Earth is not flat, but actually we need two photos here. I'm switching between two frames. Everything is almost identical, the state of the atmosphere and so on. Only the wind turbines turn slightly, making it seem like these two frames were taken a short time apart. And that's exactly the case. These two frames were taken just a couple dozen minutes apart, with the same camera, the same settings, the same zoom, and almost from the same geographic location. The only difference is the height from which the shots were taken. The first frame was taken near the water from a height of about 3 feet above the sea level. Now watch this. We switch to the second frame and boom, a significant portion of land that was previously invisible suddenly becomes visible. Before the water reached up to here and now it doesn't. And of course it's not about the waves, there are hardly any there. The second frame was taken from a height of 320 feet. Flat Earth proponents try to explain the fact that objects at sea gradually disappear beyond the horizon in several ways. They say that when you look with a naked eye, the object is simply too far away, it's too small to see, like trying to spot an ant from the roof of a skyscraper. But if you use a stronger zoom, you should be able to see it. But in this case, this explanation doesn't work. The top of the cape is visible. In fact, here its tip is even farther from the observer than the lower part of the cape. By their logic, if we've zoomed in enough to see the more distant top, then the lower part should definitely be visible as well. There's a similar argument about perspective. Railroad tracks appear to converge into a single point in the distance, but when you zoom in, you can distinguish the tracks even at greater distances. However, here, no matter how much you zoom, when shooting from water, the part of the shore hidden by the water will not reappear. To prove me wrong, just show a video where, with a smooth zoom, an object like a mountain or a building gradually emerges from behind the horizon like this. Another explanation they use is the atmosphere. And indeed, if you look at the full frame, you can see that the farther the land is, the more haze there is, and the harder it is to see. That's because with every mile, the layer of air between the observer and an object gets thicker. Here we run into the same problem again. The distance to the top and the bottom of the cape is almost the same, meaning the thickness of the atmosphere is also the same. Yet you can see the top but not the bottom. Also, in the elevated shot, you can see a smooth gradient of haze over the water. In the shot taken near the water, there is a clear horizon, and the water seems to abruptly cut off at that line, almost with no gradient. That's because we can only see the water up to a certain distance of a few miles. There's a similar issue with another argument about refraction. Yes, light rays can bend, but again, the distances are nearly the same, so the effect should be the same. Moreover, the effect of refraction depends on atmospheric conditions. To prove me wrong, show how when shooting from the same point at one time, you can see the top but not the bottom of the building or a mountain tens of miles away, and then suddenly on another day with different atmospheric conditions, the entire bottom becomes visible. In short, they can't convincingly explain this. But there is an explanation and it's simple. The Earth is spherical and we don't see the lower part of the cape because it's hidden beyond the horizon due to the Earth's curvature.